let's consider the American roulette game again, and let's look at a famous betting strategy. So the strategy is called doubling strategy, or sometimes also called a martingale strategy. Here's the idea. So you start by betting $1 on red, and then if you win, you gain $1 and you stop, let's say. And if you lose, then on the next spin, you double your bet. So now you bet $2. And then if you lose again, you double again and bet $4, then $8, $16, and so on. And so the idea is that suppose, for example, that you lose $1, then you lose $2, then you lose $4, and let's say you've lost a total of $7. If your next bet is $8 and you win, then you get your $8 back, which covers the $7 you lost, and you leave with $1 profit. So the idea is that as long as you at some moment win, you will make a $1 profit, right? And so this seems like a cool idea, at least, and many people seem attracted to it. Oh, you're guaranteed to win eventually, right? And that's the whole idea. So is this a reasonable and practical strategy? Can anything go wrong? Let's look at it, right? So let's look at this. Let's analyze what we just said more carefully. So what is the probability? So you're going to start betting on red. So what is the probability that you get red in each spin, right? So the probability of getting red in each spin, let's call it P, equal to 18 over 38. So there are 18 numbers that are red. Remember that the numbers go from 1 to 36. Half of them are red, half of them are black. And then there are two special symbols, the 0 and the 0, 0, which are green. And that's why there are 38 options and 18 of them are red. So this is the probability that you get a red. So now what's the probability of losing n spins in a row? So now the probability of losing n spins in a row is going to be equal to 1 minus p to the power of n, right? So in this case, the 1 minus p is 20 over 38 to the power of n. So what is the probability that you're going to eventually, so that you lose n times in a row is each time you need to lose. So if the probability of winning is 18 over 38, then the probability of losing is 20 over 38. And the probability of losing n times in a row is this happening 20 over 38 times 20 over 38 times 20 over 38 and so on. And of course, the main idea of the argument is that the limit of this 1 minus p n when n goes to infinity is equal to 0, because 1 minus p is less than 1, right? So if you take the limit here of this expression when n goes to infinity, it goes to 0, which means that eventually you win with probability 1. Okay, so that sounds very good. What is the catch here? Is that you need to be able to play forever. So the catch is that you must have an infinite bankroll. So the amount of money that you have needs to be infinite. And so it is true that this strategy works if you have an infinite amount of money, because then you can just wait and you're going to eventually win. But that's typically not the case. You don't generally have an infinite amount of money, and that is going to be the issue with this strategy. Now let's think about realistic play. So as before, let Q here be the probability of losing on one bet. And suppose that because your bankroll is finite, you can't lose forever. So you can take at most n consecutive like let's say that n is the limit of the amount of times that you can lose, right? So now the probability of losing n bets in a row, so let's write that out. So the probability of losing n bets in a row, so that is going to be q to the power of n, which is 20 over 38 to the power of n. So this number may be small, but it's not zero. And this is what's going to be the key point. And so the idea is that a small probability of disaster is still dangerous if you repeat this strategy many times. So if each attempt has a probability q to the n of ruin, then the probability of avoiding ruin in one attempt, so the probability to avoid ruin in one attempt is 1 minus q to the n. But if you use this strategy too much, if you make, let's say, m attempts, now it's going to be 1 minus q, to the n, to the power of m. And so the problem here is that if you play more and more rounds with this strategy, so if you apply this strategy too much, what will happen is that the limit of you avoiding ruin, so the limit of the 1 minus q to the n to the m when m goes to infinity, this will be equal to 0, because this 1 minus q to the n is always going to be strictly less than 1, and so the limit doesn't matter how close to 1 this is, since it's never actually equal to 1. When you take the limit of applying this many times, this goes to 0. And so what this means is that if you keep playing long enough, eventually you're going to hit a long losing streak. And so this will happen eventually. And so the doubling strategy creates many small wins, but it also creates the possibility of one very large loss. And if you play enough, this large loss will happen. And so you're eventually going to lose all your money.